Alrighty, testing. Cool, let's go ahead and get started. So in today's stream, we're gonna continue with the Unreal Engine and MetaQuest Pro. So just to go over what we're doing, we went ahead and Oculus, this one. So we're using a branch of Unreal Engine that is, or a fork of it, coming out of Oculus VR, which is obviously the company that was acquired by Facebook, now Meta, that created this headset. We're using the Oculus 5.0 branch. There's instructions here on how to run it on Windows. This is a Windows, but basically you use Visual Studio, which is the purple VS Code, has the kind of build tools. Specifically this .sln, which is a Visual Studio solution file. Yeah, and then you open it in Visual Studio, and you get this UE5, and then you hit build over here. And then once you build it, you want to do development editor, Windows 64, UE5, and then go ahead and run it. And that'll give you the editor. In terms of the project that we're actually running here, we're running the pass-through sample. So let's open up the File Explorer again. Inside this fork of Unreal Engine provided by Meta, there is a samples folder, and then inside of that there is a Oculus folder, and then within that there is this here, pass-through sample. And you can open this Unreal Engine project file here in the editor. And that is the scene that we have here. So just for context, if we go to project settings, in previous videos we spent a bunch of time trying to figure out the magic combination of things that work here, and I kind of just tried a bunch of things until it works, and this is what I currently have. SDK 29, target SDK 30, SDK licenses accepted. If you go into the Android SDK, I'm using a NDK or Android NDK of 21.4.7, and then the Java and the Android SDK come from NVPack. Kind of a weird setup. I don't think this is actually supposed to be the official versions of those SDKs and NDK packages, but this one actually works, so we'll go ahead and do that. This window here, so we have the MetaQuest Developer Center or Developer Hub or something like that. MetaQuest Developer Hub. This is kind of an application that you can use to connect, in this case, with our MetaQuest Pro. Useful here, you can hit the logs and you'll get the logs. Unfortunately, there's a lot of spam here. Like, there's a bunch of camera failed, buffer returned. It's actually quite amazing to me that you can have this many errors on a device that's just kind of sitting there idle. But it's useful for debugging. So one of the settings that, some of the settings here that I think are important are right here, ADB over Wi-Fi. So Android debugger over Wi-Fi, you want to hit that on so that you can disconnect your headset and try out your Unreal scene without having to move. I turn off the Guardian and the proximity sensors so that, right, a lot of times you're interacting with the desk and it gets very annoying. So by turning those things off, it makes it a little bit less annoying. I'm going to try to cast from this headset so that you guys can kind of see what's going on here. Okay, so there we go. That's what the headset is seeing. This is the home screen, home environment of Khazad-dûm, I think, which is the dwarven city in Lord of the Rings. Let's go back to our Unreal Engine project and then to our Quest Developer Hub. So, then let's bring this to the front. Let's make it a little bit bigger so you can see it better. Okay. So, up here, we went ahead and we built this for our Quest Pro. There's two of them that show up here. I'm not exactly sure what that means. But once you build it, it'll actually show up here. In the MetaQuest Developer Hub, there's a little kind of bar here, or section here, that you can look at your apps, and then within those apps, you can see here the PT sample pass-through sample date created and the version, and you can hit launch. So it was working yesterday. We're gonna see if it still works today. So let's go ahead and click launch. We see on the headset the Unreal Engine popped up, and there we go. We have the actual pass-through with the controllers and everything. So there we go. So it's looking good. Go ahead and stop that, and it should return us to our home environment. So we have the Quest Pro working with Unreal Engine. This is Unreal Engine 5 too, so quite crazy. So we don't have Lumen and Nanite yet. Lumen and Nanite being kind of the key technologies from Unreal Engine. Unreal Engine 5. Yeah, Lumen is a global illumination that's dynamic. Rendering, dynamic global illumination, reflections, and basically it just calculates lighting real time. So we're actually going to be looking at some lighting. I don't think this is going to be Lumen lighting, but it should be interesting. So let's go ahead and open this back up. So we have our scene here, and we have our player start, player camera, player start, light source, skylight. Okay, we have a big overhead light here, and then we also have a little light. So I'd like to, if we look at the details of this, for example, light source. This is a stationary light. Only have its shadowed and bouncing lighting from static geometry baked by light mass. All other lighting will be dynamic. And then movable, can be moved and changed, totally dynamic. So why don't we go ahead and add can we just add a basic shape here? Let's add a cube. Okay. Okay, let's see how big this cube is. This cube is a little bit big. We're gonna select that cube. Maybe there's a scaling. No, there doesn't seem to be a scaling. So we're gonna, oh, what did we just do there? Yeah, so WER. Okay, so WER, we have W is movement, so let's go ahead and move this cube down. Okay, now it's intersecting with the floor. We can go ahead and move it. Damn, this is kind of hard, honestly, right? We hit the F key to focus on this item. So actually, why don't we try to scale it down here? Let's do 0.2. So we're going to make it a little bit smaller. Okay, so we have our little cube. It's casting a little shadow. Totally dynamic, casts a dynamic shadow. Okay. Now let's add. Oh, I just hit Control A and it went to the camera. Let's add another shape. This time we're going to make it a sphere. So bring it out of this dark zone here. And let's also scale it. 0.2, 0.2, 0.2. Okay. And let's make this one static. Sure. So really, kind of what I want to eventually compare here is the shadow quality, kind of the differences you get between kind of movable, static, the different options. So I wonder if we can turn off this skylight. Let's, can we just straight up delete this? All right, we're gonna delete the skylight. And this light source, we'll leave it like that. So let's go ahead and save all, Control S. Lighting needs to be rebuilt. 2 unbuilt objects. So light source, we want a movable light, 1 unbuilt object. Okay, so there's another light in the scene that is producing light. Maybe it's this. Let's delete the atmospheric fog. Okay. There we go. So now we've deleted the atmospheric fog, and the only light we have in the scene is this light right here, which is directional. Let's go ahead and maybe we can change the direction of this light beam. I wonder if it's maybe... Is there a point that it's pointing to? I think maybe if we rotate it. Yeah, let's rotate it a little bit just so these shadows are directly below. Okay. We're going to save our scene. And let's try to quick launch it on our device here. So we quick launched it onto the Quest Pro. We're going to verify the output log here. It's going to build the executable for Android. And here we go, the settings. So today, by the way, I have some espresso. It's a little boo. She buries my coffee because I think to her it smells like poop. Boo, you don't need to bury this coffee anymore. Okay, we have the building is happening here. if we go to our MetaQuest Developer Hub, this window here, this might take a second. I don't know why it has to rebuild the entire thing, I suppose. But eventually this here, deploying executable and assets. So I suppose this will update to the current date. But we will be able to see it once it actually casts. So kind of the inspiration for checking out lighting comes from this talk that I saw recently. So this guy is the Blender guru. He's like kind of a famous YouTuber who is known for his Blender tutorials, but he has this nice video that I'll link where he kind of goes over kind of how Pixar gets kind of a realistic look, and especially when it comes to lighting. And like one of the things that he talks about here is that you want lighting to always kind of be on this spectrum where natural lighting always exists on kind of what is called the Kelvin scale. So we can go back to our scene, which right now we're just looking at the things here. Okay, and where's our light? Here's our light. So there's so many windows open. This is ridiculous. We've got our lighting here. We've got our app. Okay. So again, I'm not an Unreal Engine expert, so I'm kind of making this up as I go along here, but we have the light source, directional light. Okay, this directional light has an intensity, right? We can make it more intense or less intense. Cast shadows, but then there's this color here. Okay, and this is just not. This is just a normal color picker, right? Ideally, I feel like we would want atmosphere sunlight. That's not, we don't want that. What the fuck does that mean? Light shaft bloom, visible, hidden, in game. Effect ray tracing, cast ray trace shadows, cast volumetric shadows, cast dynamic shadows. Modulated shadow color. Yeah, let's just change the color for now. Let's try something like that. All right, let's try to get maybe moonlight. How about that? See if we can sample it from here. Oh, there we go. Let's do something in between a sunlight and a skylight, so like that.
And there's your lights. So you can see that the majority of the shots in...
Okay, so now our light has the bluish tint. Let's see if this is done compiling or building. Deploying executable and assets to Quest Pro. All right. Deploy compiled SO directly to device. Maybe if we click that, it'll work. Let's hit cancel. And let's go ahead and redeploy. Let's try the IP address. Okay. Yeah, I don't know what it means when you have two of these devices here, Quest Pro and then Quest Pro, but deploying executable. Okay, this looks like it said stop, so maybe if we actually go to the headset, it's already deployed? No, it is not. Alright, there we go. Alrighty, so that is a little bit upsetting. Right, we have our we don't see these shadows in the actual game here, right? Let's see if we unplug this. So the Quest headset is plugged in right now. I want to see what happens if we unplug it. Okay, we unplugged it and it still works. That's good. But we're not really seeing the shadows that we want here. Yeah, in fact, there's 0 shadows on this. So let's go ahead and hit cancel here. Launch canceled. Okay, this will go back to the Khazad Doom. All right. So that light didn't do shit. What if we do, so this is a movable object, that's a static object. Let's make these a little bit bigger. Let's go 0.5. We'll make this 0.5, make that 0.5 as well. Make this 0.5, 0.5, and 0.5. So we have, right, the ball is static, the this is movable. We have different roughness, specular. Why don't we actually, can we duplicate this object? Sphere 2. All right, let's move it right there. Let's actually make a sphere 3 as well. Okay. So there we go. We have our 3 spheres, and let's give them different properties too. Let's create new asset. Let's make a material instance. Where is the basic shape material? VR, template, content, geometry, meshes, cube material. Okay. Drop shadow, selective, Oculus graffiti, Lambert, flashlights, widgets, maybe it's in here. VR cursor, default material. I don't know where this one is. Basic shape material. Ah, okay, there's a little button. You can browse to it. So it's inside engine, content, basic shapes. So for sphere 2, we're going to create a material instance. Looks like there's some other ones that we can select here, but let's go back to basic shape material. And let's create a new material instance. Let's put it in our geometry. No, in what about VR template materials? We'll put it in here. We'll call this one shiny. Okay. Show inactive. Layer parameters. I kind of want to see like an editor for this. Is there a way to like look at the node editor for this? Maybe if I double click on this, current asset edit. How did I get to the node based view for this? Maybe I hit save. Save. Tools. Find in blueprint. Show material nodes UE5. Using the main material node. Material graph. How to get to the material graph. Bake materials. Come on, how do we do this? Perspective. Show background stats. Details. Physics material. Oh, okay, maybe it's just the new materials when you create them don't have anything. Okay. Basic shape material. Material graph. Okay, so this has a material graph, but this does not. So what is the difference between basic shape material and this one here? So maybe let's go to basic shape material. We'll browse to it. We'll duplicate, and we'll call this basic shape material 2. All right. And we'll open that. All right, that's what we want. Okay. So now we kind of created a copy. I think what was going on here is that the shiny is a material instance, which is kind of a weird. Let's go ahead and set it to basic shape material 2. Then we'll go ahead and open that. Perfect. Let's make it a little bit more of an interesting color. Let's make it like a slightly pink sphere. And back to the video here.
And there's your
so one of the things that the guru talks about
setup
is here. So
crank up the roughness. It might seem like it doesn't make a difference, but it does, because reflective, just crank up the roughness. Always keep
So he says never keep the specular at 0.5 and go the roughness up to make the roughness higher. So what is this? Param. Can we add another param? Slider. Param. Scalar parameter. Texture sample. I think what we want is a scalar parameter probably. Okay, we'll call this specular. Okay, and then this will feed into this. Parameter name, specular, default value, let's say 0.5. And then roughness, we'll say this one is, we'll give it a 0.9. Okay. So actually, while we're here, why don't we create a couple other params here? Scalar parameter. We'll call this emissive. And let's create another parameter here. Nope, that's not what we want. How do I add? Is it A? Control A? Parameter. Scalar parameter, and we're going to call this metallic. Okay. So we're going to create a couple. The reason we're making these is we're going to basically go through all of these and see how they affect things. So emissive goes here. So I think if we hover over, which parts of your material will glow? Roughness 0 to 1, specular 0 to 1, metallic also 0 to 1. So maybe here parameters. Okay. So we'll crank up the metallic. I think this is not actually the emissive. Which parts of your material? I think this is like a. Yeah, let's delete this. Okay, so we're just going to be looking at 3 different numbers here. Metallic, specular, and roughness. So we're going to go ahead and save this. Take a sip of coffee. It's baking this or whatever. We can actually see the quest is tracking our hand, which is quite cool. All right, now that our material is good, so we have our generic basic shape material, we have our basic material 2, or actually let's go ahead and change these. Let's go to open in the content browser. We're going to duplicate, we're going to call this one 3, and then we're also going to duplicate and call this one 1. So we have basic material 1, 2, and 3. So let's go to our sphere, we're going to change this to basic material 1, and we're going to change this one to basic material 3. Then basic material 1, we're going to edit it. I wonder why it doesn't show. Ah, okay, you need to save it. Okay, maybe it froze there. No, we're doing good. shader compilation. So shaders are programs that determine the color of objects, and they're taking into account the lighting and the material and all these different properties that we're kind of messing with here. So this one, let's do a low roughness, something like point that, and let's do a high metallicness. We'll go ahead and save that. And then for our third object here, basic shape material 3, let's do a low metallic, a low specular, and a low roughness. Let's see what that looks like. We'll hit save on that as well. So let's close out of that. So we have 3 different objects here with different properties on their material. And let's see how they look in this pass-through. So let's go ahead and quick launch. I think the IP address was the one that was working, right? Save all of them, and it's going to build. All right, it's going to take a second here. So while this builds, I'm going to hit the bathroom. I will be right back. All right, we're back. So, all right, we have it running on the Quest now. So we can see the different properties here of these little objects. But you know, it's still not, we're still not getting any shadows. And I think maybe part of the issue here is that the object, is it cancel? The object is, this floor does not receive lighting. So this floor here, default material, let's actually change it to the white material that the cube is made out of. Basic shape material, this one. Okay. Floor. Replicate physics to, no, I don't want any of this crap. No physics. Enable gravity, nope. Static. This is a static object, so cast shadow, don't cast a shadow. Advanced. Emissive light source. Okay, let's see if that allows us to see the shadow. So we'll hit save, and then we will go to the quest. So what we did is we changed the material of the floor to the basic material, which is kind of one of the default materials, and then we're going to see if that makes it so that we can see these shadows. Because so far we're not seeing these shadows at all. Okay, while that goes ahead and does its thing, we can maybe start playing with the lighting source here. Sphere reflection capture. Now let's do this. The light source. So this is a directional light. Let's see kind of what other lights we can add here. A point light, a spotlight, a rectangle light. Let's do a point light. Let's go ahead and move this point light. Okay, so that it's kind of above the scene here, like this. Maybe like this. Indirect lighting intensity, affects worlds, casts shadows. It's a stationary light, so we want it a movable light. Temperature, okay. This is the Kelvin scale that the light guru, or the Blender guru was talking about. Okay, I mean, we are seeing it on this. For example, this this object here, we can see how it is kind of casting a light on that. Maybe we can move it here. So actually, there was
Keep it at
magic numbers
0.5%.
here that
If you want to make something look non-reflective, just crank up the roughness.
the guru
It
gave
might
for
seem like it doesn't make a difference, but
cinematic
it does,
effect.
because all objects are correct distance.
Yeah, 1,800K and 4,000K. Okay, so 1,800K, and that is supposed to be oil lantern. And let's go ahead and actually duplicate this. Control copy, control paste. We'll call this oil lantern. And then we'll call this moonlight. And the moonlight we're going to put here. And the moonlight is 4,000K. Alright, so there we go. That's moonlight. How do you... Oh. I don't know how the hell I got into this view, but it's actually kind of what I want. Let's put the moonlight right here. Oh, I went to wireframe mode. Let's do lit mode. How do I get out of this view here? Bottom perspective. Okay, there we go. And while we're here, why don't we actually delete this light here? This directional light. Include actor and HLOD can be damaged. Initial lifespan. I don't think we want either of these things to be damaged. I don't even know what that means. Affects worlds, casts shadows. This is still not streaming, by the way. Maybe let's hit cancel here. Okay, what do we have to click differently? Quick launch, Quest Pro. Save selected. Maybe it does need to be plugged in. We'll see what happens. If it doesn't work here, we'll plug it in. Okay, so it looks like there was some stuff there. Shader library, assets, unique shader maps, total shaders. Okay. Connecting to remote, creating UE command line. Maybe we need to hit stop here. Okay, no, there we go. Okay. Alrighty. So let's see these. So I mean, these don't look super amazing, to be honest. Let me put on the headset and see if it looks any different in the actual headset. wonder if I can move in this 3D space. Okay, and actually, there's a couple different settings here for the pass-through. You can kind of tune the amount of red, the amount of green, the amount of blue, the alpha channel. So how much is the super high alpha versus super low alpha? Okay, one thing is really annoying that this these objects are kind of far away. Let's see if we can put them, we can rotate this world and put them so that they're kind of like over here on the ground. So let's go ahead and do that. Let's put these back. Let's take this off. And let's hit cancel. Okay. So going back to our scene, wow, it just looks so much prettier in this rendered view here. Let's take all of these objects. So this, this, and this. The floor, all three spheres, the two cubes. And we are going to go ahead and just move all of this. So W. We're going to move it back. All right, so if we were here and the objects were there, I think we want them to be this way. Let's see. Save, building. It's still deploying. I don't know why sometimes it just deploys quickly, sometimes it doesn't deploy. Seems like you kind of need to do it twice just to get it to deploy. Cancel. Go back here. Save. Go back to this. Maybe we hit stop on that. Okay. And then let's go back to the Quest Pro. Look at that lighting, by the way. You got warm temperature there, and then you have the moonlight, so it's actually quite similar to what we're trying to do. While that loads, let's look at the oil lantern and the moonlight here. Point light component. Alright, here we go. Okay, so now finally we have our objects. This is really not great. Why is it so washed out? Right? Why is that so washed out? Let's put this headset on. Get a good view here. So this looks incredibly washed. Kind of looks like maybe this thing, sphere reflection capture. Okay, so this is affecting the lighting. You can see it right here. Yeah, it's even causing lighting effects on this. So why don't we go ahead and delete this? I don't know what the fuck that does. Let's delete that. And yeah, let's see if that does anything. Cancel. Save. Go back. Deploying. What else can we learn from
It's a part, it'll always feel correct.
Blender Guru here?
You know, some people
Light fall off, so he again talks about how kind of the light size matters, right? Big light far away is the same as small light that are close, but you kind of have to pick the right thing. He talked about making a correct metal material. By keeping the specular at 0.5, putting the roughness low, and then having the metallic all the way up. So we can actually do that. Let's go ahead and the first sphere here. So let's change it to what he has. He has metallic high, specular, and it's actually basically what we have. that's the correct metal. Okay, cool. This is still not deploying. Let's cancel. Let's redeploy. Okay, processing assets. Deploying. We have another light source here. Okay, so we never moved it, or we never deleted it, we just moved it. I wonder if you can disable a light. Unreal Engine disable light. Toggle effects world without deleting. Okay. So there's a effects world component to it. Okay, so this light source, okay, that's what we want. Effects world. Yeah, that's 100% what we want. Okay. We're going to save that. We're going to hit cancel here. I think maybe what we did is we hit stop on that. By hitting stop on that, maybe that helped. Deploy. I don't know why it's not. Why does it like flash like that? What the hell? If we close this. Okay, we kind of have to guess. Okay, launching on the Quest Pro. Show output log. It's cooking. Again, we have our moonlight and we have our sunlight, or oil lamp and moonlight. We can actually see how when we put this further and closer, how it affects the kind of shadows. So I think moonlight should actually be the one that's high up, and then the oil lamp should be the one that's close. Okay. So now let's look at these. Okay, so interestingly, the metallic one looks terrible. It looks completely dark. Let's see. Yeah, it looks pretty dark. You can kind of see the reflections on it. Still no shadows, but you do see the lighting on the ground. Okay, and our kind of improper metallic one is over there. That seems fine. Let's see. I'm going to see what they look like in the actual game. Put this on. Okay, surprisingly, this one here, the real metallic, according to the Blender Guru, right, where you have high roughness, or low roughness, high metallic, and 0.5 specular, just looks like a black sphere. But that one, which is supposedly the fake metal, looks better. We've got our little cat over there in the corner. Okay. So that's not good. Okay. So we hit stop on that. All right, perfect. Cancel. Launch completed. Okay. Let's go ahead. Why can't I select all three of these? I think it's because our thing is bugged here. What can we change to make this not as shit? Let's make this a high metallic. But low specular and low roughness. So now this is actually the difference here. So the difference here is the specular. Invisible in game. Light function actor okay, so how come casts shadows does not work on the quest? Let's see if we can figure that out. Unreal Engine, no shadows in quest. Nothing to do there. So what if we instead change this to stationary and lighting needs to be built. How do I... So this is a static object, static, static, static. What if we change to stationary? Stationary, stationary, and movable. Make this stationary. Unreal Engine, bake lighting. What does it mean to cooked? How do bake lighting? Okay. They're just telling you what light baking is, but build. Thing is fucking bugged, so we can't actually even see these menus. Let's launch it on the Quest Pro. Okay, so what we have different from this scene to the previous scene is we changed everything to stationary rather than movable, including the lights. So maybe because it's maybe just dynamic shadows don't work on the quest and it's static lighting that works. Okay, this is still going, still baking. Connected to remote file manager. Okay. Okay. So now we have no lighting. See that? No shadows, no lighting. So when you have stationary lights, if you don't bake, nothing happens. So let's go back to here. We hit stop, and then we hit cancel. Launch canceled, okay. Let's go back here. Let's make these movable again. And let's go ahead and make these movable. So now we're going to make everything movable, including this square. And well, I guess we'll make the floor movable too. So we go ahead, hit save, and deploy this. And we're going to launch on the Quest Pro again. So I think whenever Lumen gets released, I think that's all real-time movable lights. So generally the way a lot of games do it is that the environment will have baked lighting. So if you have things like trees, tables, those will be baked, and then maybe they'll have dynamic lighting for the character, right? Or stuff that moves. Okay, we have lighting again, but we do not have the shadows on the ground. Okay. Let's hit stop here. Okay, launch completed. So we don't actually have to cancel on the launch log thing. We just hit stop on this. So what if we do stationary, 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 stationary. Hit save. Build all levels. Pre-computes lighting. And we just want pre-compute lighting. Somehow it's trying to connect to the internet. Okay, so this is the baked lighting. It's now built. Let's go ahead and put this on the Quest. See what happens when we have baked lighting. Cooking. Packaging. This does look much prettier. Okay, there we go. Wow, this is... I don't know what that is. That's just dark is what it is. So, interesting. There's basically no lights. Now I wonder if you can see the... Yeah, you can. The shapes are there. You can see the square. The lighting is just non-existent. Okay. That's kind of gross. Let's do static, 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 and let's rebuild the objects here. Build lighting only. Okay, so now we're all in static mode. We're gonna go ahead and stop that. So static lighting, we rebuilt it. Let's go ahead and build it again. Pre-compute all lighting. So everything is static. Every object, every light is static. And then we're going to build everything. I feel like this cube has emissivity on it. Let's delete that cube. I don't know. It's kind of it's sketching me out. So let's go ahead and rebuild the lighting now that we've deleted the cube. Builds all levels. Pre-computes lighting. We might not have to, I think when we build the entire project, it might do the lighting anyways. I don't know if we have to explicitly build the lighting every time. Okay, so let's deploy it on the Quest. Save selected. Builds the executable. And let's see what that looks like. Okay. Deploying onto the Quest. It's using port 5555. All right, here we go. Baked lighting. That also looks like dog shit. Okay, so I think all we really wanted to do today is kind of just explore the lighting a little bit. It looks like there's still a bunch we don't really fully understand in terms of like what is actually possible. And whenever you build for an Android device, maybe a bunch of these different things are not enabled. It seems like kind of the best results we got were with dynamic lighting. So changing the lights themselves to movable and changing all the objects to movable as well. Save. And then launch on Android. So yeah, all we were doing today is just looking at the lights. Maybe we can start doing some game dev. Or we can go kind of more in the machine learning route and figure out a way to see if we can run a fully connected network on the Quest, which is going to be very difficult. I think there's packages such as ONNX, but I don't think they're supported on the Quest. We might have to do something where the network is running on our computer and then we're connected via Quest link, which I don't know, sounds very complicated. But yeah, let's end this with this lighting here. Yeah, this is the dynamic lighting, which I think looks the best. It still doesn't look great, but it's better than the other ones. It's me. Awesome. So